Okay, so this presentation is over selecting a statistical analysis, and you're going to choose which analysis or test you're going to use on each of the examples we cover. There's going to be 6 examples, and that means that some of the tests will not be used. And my name is Chris Osborne.
I'm Brittany Seeley.
And I'm Catherine Fozzie.
And here's an overview of some of the key differences between types of tests. T-tests and ANOVAs compare groups for differences. Correlations look for relationships between variables. Regressions determine whether a variable predicts another variable. And chi-square compares observed frequency with expected frequency. Now, we're going to start with our first example. I'm going to explain, I'm going to read the example, and then I'm going to give you some time to pause the video so you can decide which test it is, and then I'm going to tell you what the answer is and why. So, a researcher was interested in testing whether dance therapy is effective for treating social anxiety. 40 people with social anxiety disorder participated in this study. Their social anxiety was measured using the Leo-Watts social anxiety scale. LSAS scores range from 0 to 144, where higher scores indicate more social anxiety. Each participant's level of social anxiety was measured prior to the beginning of the therapy program, pre-test, after dance therapy, post-test, and 6 months after the treatment, which is the follow-up. Does the therapy program affect social anxiety? If so, how? And here's a good time to pause the video. And the answer is it's a repeated measures ANOVA, and the independent variable is dance therapy program. The levels are pre-test, post-test, and follow-up. And the dependent variable is social anxiety scores. And the reason why it's an ANOVA is because there are more than 2 levels of the independent variable, and it's a repeated measures because it's a within subjects design, which means like all of the participants are being tested multiple times. They're being tested before the therapy program, after, and 6 months after the treatment. On to our next example. A math professor is investigating whether an individual's competence in math and how they are taught interact to affect mathematical abilities. Participants will be categorized as high, medium, and low competence in math. Then participants will be randomly assigned to either be taught a math lesson by the demonstration, lecture, heuristic, or project method. Participants will take a test afterwards to measure mathematical abilities. This would be a good time to pause the video so you can decide. Okay, so it's a factorial ANOVA. One of the independent variables is confidence in math, and the levels for that are high, medium, and low. Another independent variable is the teaching method, and the levels are demonstration, lecture, heuristic, and project. And the dependent variable is mathematical abilities. And the reason that this is a factorial ANOVA is because there are multiple independent variables.
So our third practice problem is Steve wants to see if there is a significant relationship between geographical region and ownership of Apple products. He surveys 100 people, and the data breaks down as follows. So the numbers below show each region and the number of Apple product owners or non-Apple product owners in the region, and then the total is 100. So this is a good time to pause as you figure out which test this is. So this is a chi-square, and in chi-square we have goodness of fit, and we also have the test of independence. So if you want to take a moment to figure out between the two, this is a good time to pause here. So this is the test of independence. The reason why this is that form of chi-square is because this tests whether 2 categorical values are related or not. So we are looking to see if there is a relationship between Apple product owners and the region where they live. And they're both categorical and makes this a non-parametric test. Therefore, it's a chi-square test of independence. Our next practice problem is a researcher wants to know if there is a relationship between numbers of hours of sleep and irritability rating, using the bite to measure irritability, where the higher the number, the greater the irritability. So I'll give you a second to figure out which test this is. So this is a correlation, and our variables are the predictor variable is hours of sleep, and then the outcome variable is irritability, because we are looking to see if there is a relationship between whether hours of sleep that people get affects the amount of irritability they feel. And the keyword in this problem is relationship, which is a good note to look for correlation.
Alright, for practice 5, we've got Professor Green wants to determine if the students in her class will perform better on a test studying in a very well lit room compared to studying in a room with much softer lighting. She randomly separates the class into 2 groups, with each group studying for a set amount of time and only one of the lighting conditions. She will then administer a test after 3 weeks and compare the students' scores. I like to start off by isolating the independent variable and dependent variable and using the chart that we had, or the questions that we had, to eliminate which tests we aren't going to use, and it's only going to leave us with the right answer. And for the independent variables, we've got our study lighting, which is with 2 levels of very well lit and much softer lighting. And then we've got our dependent variable, which is going to be the test scores. And looking through the questions, you're going to have to determine whether or not there's more than one independent variable, which there's only one, so we know it's not factorial ANOVA. Then we look at the levels. We've got 2 or less, so we know that it's going to be one of the 2 types of t-tests. From here, we're going to have to figure out which one, and we look at the fact that we've got both groups are only testing one condition, which means that it's going to end up being between subjects and not within subjects. And that eliminates the independent and leaves us only, that eliminates paired t-tests and leaves us with only independent t-tests. For practice 6, we've got Dr. Dawson, who wants to examine how animal interaction impacts a person's mood. He has a group of 10 people individually sit on the floor in a room with 5 puppies for 30 minutes. Their mood will be recorded before and after the puppy session, noting how much it either improved or worsened. Doing the same thing, we're going to look at our independent variables, which is going to be the puppy session, and it's got 2 levels, being before and after. The dependent variable, of course, being the participant's mood. With this one, we go through all the same levels as we did, only one independent variable, so it's not a factorial ANOVA. We've got 2 levels or less, so it's not going to be any other kind of ANOVA, and we're left with only t-tests. And now we have to determine whether it's within or between. And since we've got all of the participants doing the same thing, but we're recording it twice, it's still going to be it's going to be a paired t-test this time, because it's going to be within subject. And that leaves us with the paired t-tests.
So in conclusion, these are the 6 tests that we covered in our presentation. The number correlates with the practice problem that we went through, so that y'all have the answers in a simple format. Thanks for watching our presentation. We hope that you all learned something and that this was a helpful review for the final coming up, and that hopefully it cleared up some questions.